Good morning everyone. Today we are going to learn about routing algorithms and its types in networks. I am Sasikala, Assistant Professor of Computer Science, the Standard 5 Oaks Rajaratnam College, Sivagasi. The objective of today's session is to learn about routing algorithms, why it is important in computer networks and its real-time applications. So routing algorithm is simply a method used by routers to find the most efficient path to forward data packets through a network. The main goal of routing algorithms are to ensure the data is delivered accurately and efficiently, to minimize delay, cost or other performance metrics, to adapt to changes in the networks such as failures or conjunctions. The routing algorithms can be classified in two ways. One is static routing, another one is dynamic routing. So static routings are manually set by the administrators. It is simple and has low overhead but cannot adapt in the network's changes. Best suited for small or stable networks. In dynamic routing, routers update routes using routing protocols. This makes the networks adaptive and scalable. For example, RIP, OSPF and PGP are dynamic routing protocols. With dynamic routing protocols, we have three important categories: distance vector routing, linked state routing, path vector routing. Distance vector routing, the routers share information about distance and direction to reach other networks. For example, routing information protocol RIP. In link state routing, where each router builds a complete map of the networks and calculates the best path. Example, OSPF, Open Shortest Path Protocol. Path vector routing used in large scale networks like the internet, where entire paths are exchanged rather than just distance. Example, BGP, Border Gateway Protocol. Let us compare these algorithms. So distance vector routing algorithm can be slower to converge and prone to routing loops. Link state routing algorithm is faster, more reliable, but it requires more resources. Path vector is designed for large scale networks and support polysythesis. It is more complex. So each algorithm has its strength and weakness depending on the network requirements. So routing decisions are not random. They are based on some metrics such as hop count, bandwidth, delay, cost, load and reliability. Hop count means the number of routers a packet must pass through. Bandwidth, the capacity of the path. Delay means time taken to travel from source to destination. Cost, it can be assigned by the administrator, and load means traffic on the path networks. Reliability, how the path is dependable is. These metrics help the router pick the best possible route. The key goals of routing algorithms include correctness, which always provide a valid route. Simplicity means easy to implement, able to handle failures and avoid routing loops and oscillations, and it ensures no node is overloaded. It must provide efficiency, fast delivery with low overhead. Routing algorithms are used in many types of networks, including local area networks, wide area networks, the internet, BGP we already discussed in path vector routing algorithm, data centers, mobile ad networks, software defined networks. This shows their importance in all forms of communications. So to summarize, routing algorithms are essential for guiding data through networks. The main types are distance vector, link state and path vectors. They are used in real world protocols like RIP, OSPF and PGP. Without routing algorithms, modern communication networks would not function reliably and efficiently. So thank you for listening. I hope you now have a clear idea about routing algorithms. Thank you.